Hello world, and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart, architect at Atmosera, and today we're going to be doing a video on a survey of different open source databases on Azure. Hi guys, today we're doing a video talking about the open source databases on Azure. We're just going to do a survey of these databases to kind of familiarize you with the many open source databases that are available on Azure through a number of different offerings. So the first database I'm going to talk about is MySQL. Now MySQL is very popular in the open source world. So in the early 2000s, when PHP really became popular, there was associated with it the LAMP stack, which is Linux, Apache, MySQL, and PHP. And the LAMP stack was widely popular for many different kinds of applications, especially around content management systems like Joomla and WordPress that both use PHP and MySQL. And because of that, many of the online providers for hosting websites would have MySQL implementations as well as the ability to host any number of PHP-based applications. And since that time, it really has not lost any of its fervor for being very popular in that space. So it's still widely popular in the open source world on Azure and other hosts as well. So many of these other applications that were traditionally hosted on web hosting platforms like DigitalOcean or other platforms like that are moving over to platforms like Azure, which are more general purpose and cloud oriented, but still you want to be able to maintain these same kinds of applications and expand them using some other offerings as well. So MySQL still is very popular for that purpose, and it has many different offerings on Azure for that reason. So it's very popular in the open source world. There's two primary offerings on Azure, and these two are really oriented around the kind of use case that you might have. The first one is the single server offering, and this is basically just a standard offering. It's kind of an out-of-box experience that you would get if you were to install MySQL on a virtual machine, but instead of installing it on a virtual machine, it's provided as a service. There's very little that you do in way of configuration. It's pretty much just the standard offering, and then it's got some tunability in that context, but generally speaking, it doesn't give you a lot of tunability beyond just a few knobs and switches that you can use for it. If you want more fine-grained control over the behavior of your MySQL database, that's where flexible servers come in. And the flexible server is basically the ability to choose vCores and then associate a specific amount of RAM that's going to be associated with a given number of cores. So with that, you get a specific amount, a ratio of RAM for every core that you add to the server. And with that also comes the ability to use things like burstable cores on Azure. So if you don't need a full-time database, you can use the B series VMs under the hood and get burstable activity in your MySQL database, and that will save some money for you if you want to use more flexible billing options with flexible servers. The second option I'm going to talk about is MariaDB. Now MariaDB is a fork of MySQL. And so generally speaking, applications written for MySQL can work with MariaDB and vice versa. You just have to make sure that the apps are compatible. So if I wanted to install WordPress, for instance, on Azure, I could choose either MariaDB or MySQL, and either one of them would work for that application. You just have to make sure that whatever application you're going to install MariaDB or MySQL with works with whichever one you're going to work with. And sometimes they're not compatible. You just have to figure that out in the details and go with the recommendation of whoever is producing that application. Now on Azure, there are three different offerings for MariaDB. There's a basic one that's for non-critical and dev test workloads. The general purpose one is, again, for production-oriented workloads. Then they have a memory optimized workload. This is not one that you would get in MySQL, but this one is a memory optimized database that is, as a service, going to provide more memory for the given compute that you have for MariaDB databases. Now you can configure flexible servers on MySQL to be more memory optimized if you choose the right kind of compute, but this is just as a service offering that doesn't require you to tune it. You just choose this tier, and then it's going to be more memory optimized for different kinds of workloads that might be needing more memory rather than just the more compute that is going to be available in the general purpose offering on MariaDB. So the third option I want to talk about is Postgres or PostgreSQL, and this is a popular migration path for folks that are moving off of Oracle, and it's also just a popular database in and of itself, and many applications choose this one as their database of choice. For migration paths off of Oracle, there's some scripts that have been written that can assess and then also migrate data and store procedures off of Oracle into Postgres, but it does require that you modify application. So it's not like compatible with Oracle, but it is, generally speaking, a path that allows you to move off of Oracle into something that's open source and something that can run as a managed service on Azure. Now, there's three primary offerings on this. These first two kind of follow what MySQL did, and this last one is unique to Postgres. The single server offering, again, is more of a standard, minimally configurable option that offers an out-of-box experience on Azure that you can just basically spin this up and not have a lot of tunability to it, but it will work for many cases and many kinds of workloads on Azure. Now, Flexible Server allows you to basically tune the compute to your liking. So you basically choose a series of B cores, which could be a B series or D series, and each one of those has a ratio of RAM associated with it. And so depending on how many V cores you get, you multiply that times the ratio of RAM, and that will determine how much memory you get. So some V cores have more RAM associated with them while other ones don't. So if you need more memory optimized Postgres functionality, you can choose a CPU core that has more RAM with it and then get a larger amount of memory for your database. And of course, you can scale up and scale down that particular vCore option as well. Now, with Hyperscale, this is a completely unique offering that's within the Postgres context. Basically, with this one, you can take Postgres and distribute the data across multiple nodes rather than having dedicated compute associated with a single database. This basically allows you to have nodes associated with it, and so your data gets sharded across multiple storage nodes as well as having multiple compute nodes that all contribute to the overall cluster that functions as a database in this case. So this is great for a scale out model and for very large databases that are using Postgres under the hood. So the next two databases I've done videos on, and I'll link those in the video description down below, but they're both oriented around Cosmos DB. And the first one of these is Mongo DB. Now, MongoDB is a document database. The first three I mentioned were RDBMSs that use more of the traditional tables that use foreign key type relationships to build data models. This one uses a document database, which basically allows you to store hierarchical documents, and then you can query across those in a given container in the context of Cosmos DB. Now, what they did with Cosmos DB is basically implemented at the protocol level. And so what you end up with is a protocol level implementation, or basically the API for Cosmos DB running MongoDB. And with that, you get the compatibility with MongoDB, but the features of Cosmos DB. So with the features of Cosmos DB, you get things like consistency models that are tunable to your liking. So you can have strong consistency or eventual consistency, or some of those that are in the middle. Now, with this particular database, you have a different kind of billing model, where the other ones were more oriented around the different kind of compute that you can assign to it. This one has a unit-based model, which is RUs, which are basically request units. And this is for data consumption, so reads and writes that you have against your database. And you can either have reserved capacity for RUs, so you basically say, for my database, or my collection in my database, I want 2,000 or 40,000 RUs associated with that. And as long as you stay within that threshold, you're fine. Now, you can also do a serverless model with this one, which allows you for some scalability up to a point, but basically that model allows you to pay for only the RUs you use rather than having a reserved capacity. So either one of those will work depending on your needs. So the fifth database in our list is Cassandra, and I've done a whole video on this one, and I'll link it in the video description down below. Now, Cassandra is a column store database, and basically what that means is your data is written according to the column that it's in rather than the row that it's in, which is typically what happens when you're working with things like RDBMSs. And the reason you do that is it allows you to summarize and aggregate data much quicker if you just read the column of data rather than having to read every row and then look for a specific field that's in a column like you typically get with tables. Now, like Mongo, this one has a protocol level implementation of the Cassandra API. So this allows you to use many of the Cassandra applications that are out there with this particular database. Under the hood, though, it's not really using Cassandra, it's using Cosmos DB. So you get all of the tunable consistency that you get with Cosmos DB and the RU based billing model that comes with Cosmos DB as well. So the last database I want to talk about is Redis. Now Redis is an in-memory database. It's most often called a cache because it's most often used for caching values, but you can use it for a number of things, and it has some built-in querying capabilities, but generally speaking, it's used for storing data so that you can retrieve it fast, because everything in Redis is indexed and stored in memory rather than being written to a disk. And so it's used for caching values so that you don't have to make as many round trips to a database. It's used for session management. It's used for caching content so that you don't have to read that off a disk. And you can use it for other types of data to accelerate data storage and retrieval because you're writing it to memory rather than writing it to a disk, which is, again, orders of magnitude faster. So it's usually used for accelerating applications. Now, Redis is highly scalable on Azure. It has a bunch of different tiers that you can choose from, and each one of these tiers increases the throughput and the capacity that you have available for the amount of memory that you have. So you start off with basic, then you go to a standard, then you go to a premium tier, and these are kind of the baseline right here for most of the folks that are going to be using this. If you get up to enterprise and enterprise flash, what you end up with here is some scaling that comes with this. So we basically have some clustering technology under the hood. Then this allows you to have much larger database caches that can serve entire organizational oriented workloads that are for enterprise level applications, while some of these other ones are going to be more for standard applications that are just using Redis for some caching of values or session-based caching and those kinds of things. So we just walked through 6 different databases that are open source databases available on Azure, and these are as listed. We had 3 relational databases with MySQL, MariaDB, and Postgres, and then we have a document database with Cosmos DB using the Mongo API, then a columnar database with Cassandra, and then of course an in-memory database with Redis. And these are the different offerings that you can get for these. There are varying options depending on which one of these that you choose, and we try to walk through each one of those. So it's not necessarily a consistent set of offerings that you get across all these databases. But bottom line is, if you're using a database on premises, or maybe on some other cloud, or maybe on virtual machines in a cloud, there might be a way to migrate off of that onto something that's platform as a service if you're using one of these popular open source databases. You'd have to go in and try to figure out the compatibility your app has with these databases, and then figure out which one of these offerings is going to work best for your databases. And there's a lot of ways that you can migrate data from existing databases, such as MySQL on a VM, into Azure. There's some utilities and tools for that. And then you can also migrate off of unlike databases with something like migrating off of Oracle onto Postgres and so on. So basically just try to figure out which one of these is going to work for your application, and then try to figure out which one of the offerings is going to work for your application, and then try to figure out what the migration path forward for your application is going to be. If you like this content, please consider checking us out online at www.winelect.com, where you can find several blog entries about topics related to Microsoft Azure and software development. And you can also subscribe to this channel by clicking the subscribe button below and then clicking on the bell icon to receive notifications when new content becomes available. Until next time, thanks.